Right. So really, I think the title of this talk could be to answer that #1 survey of more data. So how do we get more data? How do we interact with our ecosystem to get more data? What are we doing to provide more data? And that's what we're doing. So this is my first geology talk, which is quite exciting. And so before I got let loose into the wild, geologists had me run through my talk. And they said, all right, to keep everyone interested, you should kind of get to your endpoint first. That's the motivation when you start talking about architectures and stuff. Made me a bit flat because the point of my talk is really, if we get this right, hopefully you might never hear from me again. That's okay. So I have this dream of continuous integrating data sets. And so that's when the data comes into our lodgement portal, we take that data, it flows into our system. Got my remote. The data flows into our system. It's automatically passed out. So you know humans are touching it, aka me, Kate, Matt, everybody involved. When that data is open filed, it's automatically released and everybody can connect their systems, models, whatever they want to that data. So that's what we're building for. That's what the GDMP project was all about. So we're already there with our reports and open filing. So reports get submitted, go into the system. As soon as they're open filed, they're automatically released. And we're continuing to build on this concept. If I'd be a good employee and give a plug to a couple of weeks ago, the department released the Resources Industry Development Plan, draft version. Mentioned the word data 38 times. I'm going to push for more. But really for us, the GDMP project really allows us to implement a lot of solutions to those points in that plan. It's also a great time to be in the department. There's a heavy focus on it. We can keep pitching ideas. There's kind of that commitment to keep going forward as well. Oh, what was I going to say here? So I was going to make a really elegant point here, and it kind of got blown out the water. So I was going to say that we're here, and we're all about. We recognize that we're in minerals exploration, and not everything's black and white. And so we're all about supporting that decision making, and you're not going to hear us make really big calls, such as we're going to find a new Ernest Henry deposit. But yeah, literally blown out of the water before, Joe, so I'll just move on. All right, so I have to summarize the GDMP project, which was a huge project, years of work, lots of people. So I'm going to simplify it. I'm going to skip over a lot of stuff, but it can be summarized as we had 6 different legacy systems capturing our data before. That kind of brings all the problems that you can imagine in terms of consistent controls of that data, linking it, providing it all out. GDMP, in a real simple way, is that we combine all of that into a single data ecosystem. So we accept over 70 different report types currently. That all comes into the same system. It means that we can now link all of our data. We don't accept free text. We're very controlled in what we have, and then we're able to serve it out and make it more publicly available. So very simply, this is what our ecosystem looks like. Data comes in from the lodgement portal, from whoever, internally, externally, and we store that in our Amazon S3 bucket. When that data becomes open release, you can access that through the open data portal. That release is automatic, as I mentioned. Kate's just gone through how you can connect to that open data portal via the API and do a whole range of things. We also have what's called Amazon Redshift. So that's our data warehouse. That's where we store our tabular data. And so that's a SQL database. So Kate and I spend a lot of time writing SQL code. We can connect to that using things like Jira's Globe and dashboards. And we can also serve out tabular data that way as well. So what did the GDMP achieve? I guess what's our current state? It's been in operation for about a year now. As I said, we've got a single system and we accept over 70 different report types. And so I'll say minerals are the most important report types that we're getting, but we're getting everything from geothermal, coal production statistics. So we're all controlled in that system. That makes it flexible. We can easily change, respond to requests, implement changes when it's needed. I keep mentioning this simplicity. So our data warehouse, we only have 40 tables in it. So when you think about the range of data that we don't have a data warehouse, and we've all seen it where there's hundreds or thousands of tables. What does this information mean? How do you get it out? we have a real simplistic structure. That allows us to control how we present that data. We have a really strong internal protocol for our curated layer. I won't mention that too much before, but if anyone wants to talk curated layers, please come and speak to me. On our open data portal, at the moment, we've got about 62 terabytes of data. I didn't cheat, include really large surveys that makes it, what, hundreds of terabytes, 169,000 data sets. We can keep track. We get tens of thousands of visitors per month. We know where they are coming from around the globe. And we also have lots of collaboration nationally and internationally as well. So I'm just going to mention two things that underpin our data system. The first one is vocabularies. And this is how we standardize our data. Now, I'm going to do a terrible job explaining this because it's obviously a lot more complex, but really it is that nothing that goes into our system, whether it be us internally or externally, when we have thousands of people inputting data, is free text. Everything is controlled, and we control that through the vocabularies. So if you go to Google and you type in driver and you look at the images, you're going to come up with a range of results. In our system, driver means one thing, and we define that with our vocabularies. So there's no confusion around that. And the other thing is that these vocabs are all linked. So we define the relationships between them and the hierarchy. It means you don't have to assign hundreds of labels to it, but we can infer all those relationships. And I'll bring up an example for this. It's probably a bit small, but if you go onto VocPres on our GitHub page, you can look up our vocabs. I was looking through the database the other day, and I found Zeppelin in there. I was like, all right, why do we have Zeppelin in there? Turns out that's an alternative label for airship. Why do we have airship in there? Went to the vocabs. We have a very precise definition of what airship is. And turns out, well, it's a type of survey method, and it belongs to the hierarchy of airborne. So if we can, so you can infer all that, and you can query that using SQL. You can query that using Sparkle. You can go to our GitHub and you can read it. Now, these vocabs are all about collaboration. So anybody can go on there, and if you don't agree with my definition of airship here, pull a fork out, make a recommendation. Hey, we think it should be this. And so we have organization with other surveys, other departments within the government, so Department of Environmental Sciences. We literally have tens of thousands of vocabs, and we're trying to improve that standardization across. So that means searching free text is probably the hardest thing of any database. If something's free text, you're not going to have any standardization across it. So these vocabs are really important. And you can chat to pretty much a lot of people in the survey about these vocabs because they are a big part of what we do. All right, templates. So the other big change that we made was that we were receiving data from templates, and we provided these templates around, this is how we want the data coming in. So this is all about not how we plan to serve the data out, it's all about how we receive it. And it's really important for standardization and extraction. So that number one request is that we get more data, and particularly tabular data. We can't do that if we don't have standardization of the data coming in. So yeah, I'm going to bring an example here. I've been looking at geochemistry data, and we'll kind of get to that at the back end of the talk. I was looking at some soil geochemistry files. Here's just some of the over 250 ways from about 300 files that copper was recorded. So we've been asked to try and create this into a database. But when we have copper being listed in 250 different ways, you know, we could have a go at cleansing it, and we are. But nobody here is going to have a high degree of confidence in that data because we've had to go on and transform it in some way to make it consistent. So that's what the templates are all about. I'm going to run through an example later on. Interacting with our ecosystem. So one of the ways we connect GeoRes Globe, we connect it straight to our data warehouse. So we have pretty good control over that. Means we can easily put new layers up. So earlier this year, we had, I think it was about 28,000 new reports released with the change in the open filing date. We were able to create a layer on GeoRes Globe pretty easily to show those 28,000 new reports. So that was just another way to interact with the data. Another thing that we've been working on is updating the borehole layer, and specifically on the bottom here, that's on the left, same images, just the right's 3D. That's all the cores that we hold at Zilmia and here at Mount Isa as well. So we're trying really hard to update that layer. It's in UAT at the moment. And if anybody wants to have input on what that new borehole view will look like, please come speak to myself or Courtney, just behind the pillar there. And just to keep on this theme of that, the ecosystem is really designed to allow people to interact and do a range of different projects with it. And these are from big and small. So we know of a company who, they scrape our open data portal every 2 or 3 hours, every day. And they take all the new reports, they take all those images out of the reports, and they've created an image database. You can go do little small things as well. I was going through the GitHub page, and also Kate had put up an example, how to use the API to search for reports within an area. So you provided a bounding box. I put a few lines of code in, and I created it as an email notification. So each day it just runs in the background of my computer. And if there's a new report released in that area, I get an email notification. And so it's really just to show in this example that what we've designed is made for people to interact and develop, and not just for us to keep building tools as well. My final point about interacting with the data system, that Amazon S3, our open data portal reads everything from the Amazon S3 bucket. So you should let us pay for the cloud storage costs. You can read the files directly without having to download them, and they update all the time. So example of this, I think we've got about 40,000 LAS files on there. So I know the wrong audience for the LAS files. Built a little app. You can just enter any LAS file name. This app just reads it straight from the open data portal. And you can get the tabular data out of that as well. So I'll leave it at that for interacting with our data system, and I'll get back to templates. So I'm going to use geochemistry as an example of why we think these templates are so important and why it's a big push. So we have the Queensland Exploration Database. Joe's been mentioned a number of times. Joe built his geochemical toolkit from it. It's great for database, fantastic, I love it, it's big. It was a large project finalized in 2015. There's 1.3 million soil samples in there, 700,000 stream sediment samples. So this is Mount Isa here. All these little dots represent a stream sediment sample that had a copper recording associated with it. So I'm really just showing this photo to show the scale of what's in there. So yeah, significant database, but there are some problems with it. First one is that it was manually compiled. So the day it was done effectively was the day it was out of date. So one of our continual requests is, can we get this database updated? The second thing being, because it was manually compiled and it had to have those transformations to get that data into one kind of standard format, there's going to be errors in there. And when people find, they might not be significant errors, it might only be a small sample, but people find those errors and we lose confidence in that data. So I've been playing around looking at, well, how can we update this database? So we've got about a 10-year gap from 2010 to 2020 when we've implemented the new templates. So I've gone and I started going through all the thousands of text files that we've been receiving our geochemistry data over the years. So I started with soil geochemistry, and it's been really quite a bit of a slog at it over the last few months. So we had 600 files, and they were the ones which I was able to find out in the same format. They had 7,000 different column names. So where do you start with that? It makes it really difficult. How do we update this data? And so how do we fulfill that request? That number one request we get more tabular data when we have 7,000 different column names. So it's why we need that standardization. So when I had to go, I focused on just getting the locations out, see if we can actually find that data. So everything, this is Mount Isa here, everything in green here is a soil sample that was in that original Queensland Exploration Database. Everything in purple is new soil data that I've pulled out from existing reports. So you can see that we do keep on getting new data that fills in these gaps. So I got about 250,000 new soil samples out of that, trying to put it into tabular data. We're looking to talk about increase 20, 30%. But again, very difficult. So I went and I found 50 reports that had used our new standardized templates. In half an hour, I was able to generate a complete database. There was no manipulation of the data from me. It was literally what was submitted. 250 new drill holes, thousands of related samples to that, 13,000 new surface samples. So we estimate we get 3,000 new drill holes a year. So if we move to these templates, this is what's offered. We have continuously updating databases. All this data is accessible. And this is just geochemistry. This applies across to all of our data. If I go one step further, I'll go back to my final point, is my continuous integration dream here, is that if we have that data coming in those templates, we can set it up so there's no people involved in this at all. I won't be touching it. And the workflow would literally be data comes in the lodgement portal. We pass that data from our templates into our data warehouse. We write that SQL code to make it from machine readable to people friendly. So we serve those data sets however is requested. We could make a specific subset for gold in an area. We could develop for a database that has a specific method in there. As soon as those reports become open filed, because all that data is linked to that report, the associated data will that become updated into our database. That will be on our open data portal, public facing. Anybody can go ahead and connect that model and be continuously updated. So Steve's got his work of UDStream Euclidean, where they're connecting to our API, but they're having to pass out the data from those templates. It's actually quite difficult. If we gave them ability to connect straight to a database, all their time could go into development instead of data formatting. And so that's what we're really working for. The infrastructure from GDMP is there, and it's what we're pushing for. And so hopefully in a couple of years, I won't be here. So thank you very much.
So you're working yourself out of a job, Dave?
Artificial intelligence.
Okay. There's a question here, but it's probably more for Helen or Rick. Will the presentations and the links contained in them be available for download or view, and when? Yes. So we will need to do some cleansing of some reports, maybe, just to some of the industry reports, maybe to ensure that they're comfortable with the information being released, but we will be putting them online and on the videos on YouTube, I imagine, Rick. But yeah, keep an eye out on that, and we'll publish the information when it's available.
In terms of the recordings, I'm going to speak for Rick. It's very time consuming, and Rick does it, and he's a busy man. So I don't even want to say before Christmas. Oh, yeah. It'll be before Christmas, the videos will be up on the website. If anybody doesn't want their video recording up, please let us know. I have touched base with most of the industry folks, but anybody else, just let us know. Otherwise, we'll assume yes.
GSQ doesn't have a say anyway, but ours are going up online. Are there any questions in the room? Yep.
Not a question really, more just a comment, which building the digital earth model, the work that Dave's done on the geochemistry has made our life so much easier. It's really, really good work. So I think that emphasizes the need for data standards and templates, because with that, although it's painful initially, it's going to just benefit the whole industry in being able to get the data out to everyone easily and quickly. And for Digital Earth, Dave did a great job. So we now have, what was it, 170,000 geochemistry samples or something?
Okay, 5 million.
5 million. Yeah, we've got all those in the Digital Earth. And we didn't do that. David did that. Oh, I did have one question though. You're talking about removing the human from this process. Is there any thought given to human in the loop just to make sure there is a final check on things not going wrong?
All right. So I mentioned the curated layer before. So the curated layer, in terms of how we're serving out that data, that's effectively SQL code. That's highly controlled and reviewed and updated. And then in terms of our system part of it, I think maybe the big one would be the private versus the open data. And that's our private data and our open data sit in completely separate buckets. And then we can also add in statistical process controls throughout those Lambda transformations, which we already have. So we add in those checks that happen on every transformation. And if they fail, then it all shuts down. So it's not, So we do add those human controls, but we program it in so it happens on every transformation step consistently.
I had a question, but first I had a statement, and that is that I aspire to the day when I can say to someone, I use Levenstein distances. And then I'll wobble my head and look superior. My question is much more on the other end of things. I'm going to get away from the speaker there. And that is that whenever I see API, it's a mental block I have. I think I sort of go, ooh, API, I don't know how to, that sounds like I need to be a programmer to deal with that. And I guess my question, I was thinking about, well, what is my question? I mean, you're saying it's very easy, but the question is, I'm imagining that I'm sitting in ArcGIS or MapInfo or QGIS or something. What do I do to directly access, say I want to look at the stream sediments or soils from a certain area, and I want to apply some sort of filter to it using an API. Can I do that within QGIS or one of those packages? And how easy is it? And then the third part of that question is, are there examples included on the website that allow people to do that?
Short answer, yes. So in a lot of those tools, the data source is an API. So you can just, when you're connecting to a data source, you connect with using the API and it pulls that data back for you. And on that Open Data API GitHub site that we've got, there's a stack of examples and also some instructions on how to build your own if you're after particular data sets. So, and of course, reach out, yell out. If you can't figure it out, that's what we're here for.
I'll just add on the final part of that is that if we talk about being able to build these databases from the templates, we'd serve them up as you could, like any other CSV that gets downloaded from the website. So you could connect from there. So that would be in addition to the API as well. And you can use Power BI dashboards. We have examples of people using API and Power BI to connect to the ODP and stuff.
How many Power BI users do we have in the group? Raise your fingers high as you know how to use it.
That was with the petroleum engineers. So I went.
I guess I'll answer that as well, just to add to that, as a geologist and not a computer scientist or data scientist or geophysicist, whatever. As more of a geoscientist than a data scientist, the APIs are quite easy to access. They're in a very readable format to do these queries. And there are a lot of examples on the website that a lot of my activity using Python has been to take an API script that David or Kate have written and then hack it to find that. And the other thing is they're all based on RESTful APIs. So there's a whole bunch of documentation around RESTful APIs. It's a standard method of API. So there's a lot of people that deal with RESTful APIs a lot of the time. So there's a lot of help out there as well. And emailing the team here, they can always help with a bit of that nuance around the Open Data Portal API as well. There's another question up there as well.
Yeah, David, I just had a question around when data goes open file. Does that mean before it becomes open file, it sits on a different database, or is it all in the one database and there's like, I don't know, a block that keeps them separate?
Completely separate. Yeah, so completely different storage buckets.
Cool, thank you.
Terrific. Oh, there's one more.
Got one more. Is there a public feedback mechanism? So rather than people getting disgruntled with the data sets, if they're noticing errors, that they can feed that back to you, and you guys leverage the industry know-how and local knowledge?
Yeah, 100%. GSQ open data. Those requests, they go to one place and they always make their way to us. So yeah, that's the best place, or reach out directly to us. That's why we're here. Kate and myself are here, is to be the faces for it, really. So yeah, reach out to any GSQ, us, whoever.
And I guess just on top of that as well, any feature requests, any things you want to see in the data portal or access methodologies you want to use or queries you want to see or filters you want to see, send them in. I'm not promising they're going to be done straight away, but we have a whole backlog of development work we're going to do. And as we do get funding, we'll work on that development. So if there's a particular thing that you want to see in the data portal or particular filters you want to see, email the Open Data Portal email address, send them your requests, and we'll put them in there and we'll triage them as we have development time on it. Gordon.
I guess I'm sort of hearing that you can get most of the data into a usable format. What about the last 10, 15%? And what are the roadblocks to getting everything in there? So it's a complete record right back to 18 something that is completely searchable and accurate.
All right. Templates. The templates are done implemented. We won't have that problem. To answer the historical side, you're going to have to go back, and it's a cleansing and it's a hard manual process. That exploration database that took, years and a lot of money to do. And there's no easy solutions to them. I'm trying with this 10-year gap we're going through. We can set it up to at least go in stages. So instead of waiting to release that data until it's perfect, we can go, and I think an iterative approach to that is, but I think the reality is you're never going to have it perfect with that historical data.
But I guess the templates help in the way that it removes the process of dealing with the coal face of data that's coming in.
Yeah.
Once that data is coming in cleanly, then we can focus more of our activities on cleaning up some of that legacy data or investing resources in working on that resource, human resources on that legacy data, rather than constantly dealing with the constant onslaught of 10,000 reports a year we're getting or 10,000 drill holes we're getting a year.
Got to have that line in the sand, work from there.
I think I could answer Gordon's question. I think it's very difficult because we have engaged Map2Mind to actually digitize the earlier maps, because a lot of the data are plotted onto the maps. And so that's one sort of aspect. The second aspect is some of these old data are so coarse that I do question the value of capturing some of this data. So I think, probably in that respect, it's not worth capturing.
Still find it though. Open Data Portal, it's all there.